All right. Hi, everybody. So show of hand here. Just who's using the CLI? Who's not using the CLI? Who raised their hands twice? OK, some people actually raised their hands twice. I have some questions for you guys. Hi, everybody. We're the Angular CLI and DevKit team. We already been presented, so we're just going to go ahead. And I want to talk to you. We were going to talk to you about a lot of things today, but first I would just like to say that we released CLI 1.5.0 in honor of Alan Turing. Oh, yeah. Last week, sorry, November 1st. And with it came a lot of new features and a lot of improvements and bug fixes. And I want to talk a little bit about the two previous releases for a second for discussing the new features. So with 1.3 and 1.4, we introduced the build optimizer, which Filipe is going to talk a lot about. And it's an incredible piece of technology that just makes your apps faster, smaller, better, stronger. And we also released support for building Angular Universal. If you were to the keynote this morning, Jason Jean did a lot of that work, almost entire work for supporting Universal build. It's incredible. It works. It's super great. If you guys want to do server-side rendering at some point, this is the way to go. We also introduced naming chunks, which makes debugging a little bit better. And we introduced a new feature, a new library, which is called Schematics. And I'm going to talk, and I'm going to come back later and talk about Schematics a little bit for you guys, which is a workflow tool for the modern web. And with 1.5, we added even more features, a lot more. We added support for Angular 5, which comes with a new compiler, which is faster and even more powerful. We added support for ES 2015. So if you were working with evergreen browsers, if all your users are using evergreen browsers, you can get size and performance improvements by using ES 2015 output directly. And we also added better type checking with TypeScript so that your applications actually can give you more errors and more typing errors versus Angular 4 and Angular CLI 1.4. And we added this help for schematics, for custom schematics. So if you are developing custom schematics yourself, you can actually give your users, when they use ng-help, you can show all your options and everything that they can use. And we added better tree shaking and faster compilation and faster AOT compilation, mostly. Just to show you how fast we're talking about. So these are the numbers for AOT compilation and non-AOT compilation in Angular CLI 1.4 and in Angular CLI 1.5. So we we worked really hard in making AOT compilation be the default for your app. And if your app is small or medium-sized, we're talking maybe 100, 200 files, using AOT compilation by default when you ng-serve will actually give you rebuilds, really fast rebuilds. So on Angular IO website, we went down to 1.2, 1.5 seconds rebuild times with AOT, which is just a little bit shy of twice the time of JIT. So you can actually use AOT when you develop now, so you don't have to worry about errors that just come out of nowhere when you start building for prod, which is really great. And we also improved on size using the build optimizer for Angular IO. So in 1.3, we did not even have in 1.2, we did not even have the build optimizer. We introduced it in 1.3, and the numbers in 1.4 were incredible already. So we reduced about 45% of your app. And then in 1.5, we even went further than that and removed even more code. And the total is about 60% of your app from ng build prod is removed. 60% of your code will be eliminated, the code that you don't use, but the tooling doesn't know that you don't use. So we have Filipe who's going to talk a lot about that in a moment. but already we are on the way to make your apps as slim and efficient as possible. And with that, I'm going to leave the stage. I'm going to let Mike Brocchi take over. And he's going to talk about the CLI himself and the DevKit. So Mike.
Thank you. No local storage today. My name is Mike Brocchi. I've been working on the CLI for almost 2 years now, and I've been happy with what I've been doing. So today, yes, go figure, I'm here to talk to you about the CLI. But not just the CLI today, talking about you as well. Talking about what you've done with the CLI and the growth that you've done. About a year and a half ago, we released the final version. Actually, it's been less than a year. Never mind. Anyway, lots of growth. Lots of people using it. We saw the show of hands earlier, so thank you for using the CLI. The feedback you've given us has been tremendous, and that's actually US. So I apologize. We'll go British. We need to have the British office up here in order to here at AngularConnect. But yes, seriously, thank you for using the CLI. It's been tremendous. But we know that the CLI is great as it is, but we're here to talk a little bit about the DevKit, or at least I am. The idea of the CLI and the DevKit is a symbiotic relationship, and we want to talk about what or why we're moving the CLI to the DevKit, what it's going to provide, and also a little bit of a roadmap of the different things that are going to be coming in the future. But rest assured, the CLI isn't going anywhere. You'll still be able to run all the same commands. It's just some internal things that we're doing to provide additional functionality. I'll talk about that here in a sec. So why? Why are we moving logic from the CLI into something called the DevKit? Well, we wanted to have cleaner code. So we have some legacy pieces within the CLI based off of some early architectural decisions that we want to try and clean up and provide us a cleaner code base to be able to provide additional things. We want our workflow to be more testable. This way, we're providing more reliable code to you as users of the CLI through the DevKit. Flexibility. It'll allow us, with having a more sound foundation within the DevKit than what's currently in the CLI internals, to be able to provide more functionality and flexibility to provide not only us with the tooling that we need, but also other options for you to add on to the CLI as well. Also, performance. We want things to be able to run faster, and if we write more efficient code, it'll run faster. Go figure. And not just for what we're writing internally, but also things that you're running. So small things like generate, you'll see some gains with what we're able to strip out and refactor within there. And also, things like ng-build are getting faster with work that Filipe's put on as well. So performance gains from what you run from the CLI, as well as the output there as well. And also unlocking other future possibilities. So what are we doing? A lot of refactoring. The way that I like to think about DevKit and the relationship with the CLI is like Angular development. You end up and you start writing your application, you write this component, and it's like, oh yeah, I want this little thing here and there, but it's got some logic, and I add more and more logic, and all of a sudden you've got a 200-line component file. So what do? You refactor it out into a service. Think of the DevKit as the service behind the CLI. So we're basically taking all that logic that's in the CLI and moving it into a library framework. This way it's not in the UI layer, which is the command line, it's moving it into a library. So doing the refactoring there. We've already moved things into DevKit, things that we've already done. Generating with schematics, starting with Angular CLI version 1.4. Schematics was being used to generate all of your new applications, all your components, services, pipes, anything else that you generated was already running through schematics and using DevKit as a version 1.4. Also, Build Optimizer is part of the DevKit. So all the pieces that Hans was talking about that Filipe will be up here in a second to talk to you about is all within the DevKit to provide that layer of flexibility and that extra layer for us for our architecture. And also Service Worker was introduced in version 1.6. So it's kind of, 1.6 is kind of in between the now and the future, but it's out in beta. It was talked a little bit during the keynote this morning and yesterday by Maxime in his PWA talk. So improved Service Worker with the Angular 5 improved Service Worker support is there. Also, I want to talk to you a little bit about the roadmap, but not quite yet. I'll come back later and finish that up. But we want to talk about what's there now. So I'm going to bring Filipe up to talk to you a little bit more about Build Optimizer.
Thanks. Hi. OK, so I'm Filipe. I'm here to talk about Build Optimizer. So Build Optimizer is something that we introduced in 1.4. 1.5, if you've made a new project, you're probably using Build Optimizer right now whenever you do a prod build. And for projects in 1.4, you could opt into it via the -- Build Optimizer flag. So this is live right now, and we feel like it's quite mature and that we feel really good about it, so we turn it on by default. What is it, though? In the slide here, I say that it's a set of code transformations that make Angular app bundles smaller. By code transformations here, I mean that we move some code around, we add some comments, we remove tiny bits of code, but when we run that code that we generated via tooling, it gets much smaller than before. So we've gotten some numbers from Hans before. Let's see how small we're talking about here. Angular IO's app is our docs app, and we use it for benchmarks. Without Build Optimizer, it was nearly 1,200 Ks. With Build Optimizer, it's around 500. This is a big reduction. And essentially, the app lost nothing. This is just almost a refactoring of your generated code. But your mileage may really vary a bit. See, Build Optimizer works by removing unused library code. If your app uses most of the library code that it imports, there's just not a lot to lose there. But why do we need Build Optimizer? Shouldn't Uglify already take care of this? Well, the answer is that transpiled TypeScript code, sometimes it's hard for Uglify to actually drop statements out of. But we know more than Uglify in this case. We know that we're looking for transpiled Angular apps that were built using AOT. So we know what to look for here. We're looking for transpiled classes, we're looking for enums, we're looking for decorators, and we're looking for TypeScript helpers. But I should mention that TypeScript already does a lot of the transforms that we have here. Ideally, Build Optimizer wouldn't be needed. TypeScript right now does some of the transformations that we look for, but code in the wild itself, it doesn't have those transformations. So there's loads of code online right now that your apps use that still need Build Optimizer to shake out the bits that you don't actually use. The code that I'll show was transpiled using TypeScript 2.3.4. Let's see an example of what I'm talking about here. So I have some code. I hope that this is, like, everyone can read this. On the left, actually on the right, you can see the source TypeScript. And on the left, you see the transpiled JavaScript. See, so you have a couple of class declarations that get transformed into a couple of functions, and we're looking at a total of 5 declarations here. One for each class instantiation, and also one for a number. But only the class 1 is used here. And we're going to see what Uglify does to this code, and how many statements is Uglify actually able to drop. But I want to see if you can guess. Who here thinks that only one statement will be dropped? Put your hands up if you think, okay, out of this code, Uglify probably can only drop 1. Okay. What if you think that it can drop 2? Okay. 3? Do you think it can drop everything? Because, Uglify just realizes that our class is useless. Okay. The real answer is that it can drop 2. The code there that you see in red is the code that's actually going to be dropped. And you might think this is weird because, you look at the code and this does nothing. Why couldn't it drop the class 2 instantiation? Well, because Uglify doesn't know what's actually happening there. By instantiating class 2, you might be doing a bunch of stuff. You might be calling APIs, you might be changing internal state, you might be just doing a bunch of console logs, and that's a side effect. So Uglify cannot drop it. But we know that this code does essentially nothing. So what we go and do here with Build Optimizer is that we add those little comments. You see those pure comments? Those comments mean this statement here has no side effects. So we added it to the class declarations, we added it to the class instantiations, and when we run this through Uglify, it's much, much smaller because the class instantiation for class 2 was dropped. And once that was dropped, the class declaration was dropped as well. So we're looking at toy code. This code does nothing. And just by adding a couple of comments, we've dropped roughly half of it. On real code, where real classes do stuff, once you drop a class, there's a lot less code there. But this effect also cascades. Once you drop a class or once you drop a declaration, there's more stuff that you can drop. And this is how, by keeping essentially the same app, on Angular I/O we got to half the size. Now, this kind of relies on something that we know about Angular, though. Angular libraries are free from side effects. This isn't true of all libraries. So some of the more advanced transformations we can only really apply to Angular libraries, to the core ones, like Angular, Angular Core, Material, etc. Webpack 4 is actually working on supporting this concept of pure libraries so that library authors can mark on their package.json that this library doesn't have any side effects, and then Webpack will be able to drop a lot of this. Again, ideally, Build Optimizer wouldn't be needed, but tooling is getting there. Now we're going to look at the individual transformations that we apply. So because this is a pipeline, we apply a bunch of transformations, and in the end, we get the good results. This is the dangerous one, so to speak. This is called prefix functions. Here we call any function, we mark any function call as being free from side effects. And this is the one that we can really only apply to Angular libraries. My clicker is dead. No. Here we call this one prefix classes. It's kind of similar to the other one, but we look for TypeScript classes. We know that when they transpile, they look like this. And this is safe to apply anywhere. The class declaration in TypeScript is always free from side effects. This one is a little subtle. You see that there's a property downstairs, like outside of the declaration. That's in red. We're going to remove that, but we're going to put it inside of that IFI. This is very subtle, but when you look at this and when you think about what we were talking about before, about stuff not being used, just this little change made the class not actually be used anywhere but in its declaration. If that property was still outside, this class could never be dropped. So we call this one class fold. We have another one. This is called scrub file. This is the one that looks for Angular-specific things. We know that we're talking about code that has gone through AOT compilation. So we know that the Angular decorators that were only needed for AOT compilation, they can disappear. So here we look at an Angular decorator that's called injectable. We take it out, but we leave another decorator that's there. That didn't come from Angular, and we don't know if it's actually needed after AOT compilation. It probably is, because you added it. So we leave it. We only take the safe ones. And this can actually have a very dramatic effect when you use it on libraries, because it's a really good idea to inline your templates in libraries. But after we have the AOT factors, we don't need that anymore. So on libraries that have very big templates, running AOT compilation drops this big chunk of code. This is what a decorator with an inline template looks like in JavaScript. This is a bit more subtle. If you've seen bundled TypeScript code, you might have seen like these very common blocks of extends and something. This is actually generated by TypeScript. These are TypeScript helpers. As a TypeScript library author, you can actually say, I don't want to include these blocks, but instead I want to import them from tslib. But again, there's a lot of code in the wild that didn't do this. So we look for them specifically, and we replace them with imports. This might not seem very much to you, but these helpers would be in every transpiled TypeScript file. I think at some point, the RxJS published code had around, I don't know, some 200 of these. That kind of adds up. So replacing them with imports makes it a lot smaller. This is the last one, and this is a simple one as well. It's kind of the same principle as when we put that property in. We kind of don't want to have and this is an enum being used anywhere but in its declaration, so we can drop it. So before we had a variable declaration, and then we had a function that actually used that variable declaration and added the enum bits. In this case, we'll say, well, enums, we know that enums are side effect free, and we're making it all in the single declaration. So if the enum isn't used, nothing else uses it, we can drop it. The last thing isn't a transformation, but it's actually something specific of Webpack code. Once you bundle Webpack code, you get it in its own bundle format. If you look at your Angular CLI bundles, you'll probably see a bunch of these Webpack requires. That's just the Webpack version of the node require. For libraries that are side effect free, we mark these as being also side effect free function calls, so that if you're not using some part of Angular, that whole file can be dropped and not imported at all. So how can you use this? Nowadays, if you make a project that uses Angular CLI 1.5 and Angular 5, you do ng-build -- prod, and you're already using Build Optimizer. So that's the most straightforward way. If you have an Angular 4 project, even if it's with Angular CLI 1.5, you still have to use the -- Build Optimizer flag. But you can also use Build Optimizer as a standalone library. You can use it, for instance, if you're trying to make your library smaller in some cases, or your app that doesn't use the Angular CLI smaller, you can just use it as a CLI tool. You install the package, and you just run build optimizer and then the input JavaScript. You can use it as a Webpack loader plus a plugin. And you can also import it as part of your build chain. And if you want, you can also import the individual transformations, because build optimizer works as a TypeScript transformation, as actually several TypeScript transformations. And if you have a TypeScript pipeline that has your own transformations, you can just put these in there. That's going to work. But we have our full documentation and more examples that, unit tests where you can actually check that these things work as we advertise, in the DevKit repo. So I encourage you to go check there. And now I'm going to pass the clicker back to Hans. He's going to talk about schematics, which is really great. Thanks.
Thank you, Filipe. Thank you, that was great. And if you guys are not using the CLI, we still love you. You can use Build Optimizer too. So like a lot of our toolings, actually like the Webpack plugin and the Build Optimizer, you can use separately from the CLI, which is really great. I'm here today to talk mostly about schematics. And schematics is part of the Angular Labs experimental features. It's not yet ready to be, officially its own. It's part of a little bit of a nest, basically, that we call Angular Labs. And what is schematics? Schematics is a workflow tool for the modern web. And so workflows are basically when you pass from one project state to another project state. For example, you want to create a new component. That would be like a workflow. You add a component to your project. And workflows used to be a little bit like this. Basically, it's like somebody uses a file editor or a magnetized needle in a steady hand, and then just basically start creating new files, updating the files. And these are repeated often and often and often and every day multiple times. And you guys, like if I was asking you how many people in AngularJS were like creating new components every day from scratch, basically like creating a new file and calling like angular.module and everything. And so what you really need is building a script, a kind of workflow that goes from one state to another that creates. And so schematics create files. They also can rename and delete files, and they can transform and refactor files and logic. For an example of refactoring that we do, which is simple right now, but is that we add your component. When you create a new component, we add the component we import it automatically into the closest ng module. And schematics, we built schematics because what we were using before are basically just a bunch of, write file to the disk and all that. And we kind of noticed that, well, there are problems with these kind of workflows, which are like what Blueprints and Yeoman kind of use, which are when you write a file, you start the workflow, you write a bunch of files, and then like there is an error in the middle. Like you didn't npm install something that's required, or you didn't use the right file name, and suddenly there's a file that already exists. What happens? Well, the whole system breaks down. You're in this state, invalid state, where you have like half the process done and half the process not done. And so we created schematics to make sure that all the schematics are extensible, composable, and reusable. They're basically little sandbox where you get a state of the project, and then you build that state, and you pass that along. And you don't know what happens before, and you don't know what happened after. So you can actually put multiple schematics together, and all of them will work because they just work in the little sandbox, but they pipe those sandbox together. For example, our Angular application, we just put the files for creating the build, the configuration, the package JSON, the Angular CLI JSON. And after that, we call the same schematic that we use when you ng generate module. So literally, we're just reusing the same schematics that you guys that generate would be using for creating the base component and the base module and the tests and all that. And they're also atomic. So one of the great things is if something happens in your sandbox fails, but it does not necessarily, it didn't have any side effects. So it didn't create problems on the file system. And if you were part of a pipeline, people can actually just ignore the failure and say, like, well, if this fails, I'm OK with that. Just continue on to the next one. And so schematics are just basically a rule, and we'll see what a rule is a little bit later, that takes an input tree and an output tree. And a tree is basically just a map of directories and files to their content. So a little bit of code. I want to show you guys a little bit how to create a schematic. So the way you create a schematic is you define a rule factory, and don't freak out about the word factory. It's basically just a function that takes an options. The options are basically provided for you externally, and it returns a rule. So for example, for an example of options, if you run ngGenerate --x equal y, options.x will be the string y. So it can come from the command line, or it can come from another schematics, and we'll see a little bit how to compose schematics in a bit. And so a rule takes a tree, applies something to it, and return another tree. And in this case, a rule is basically just a function that takes a tree, return a tree. And in this case, we're just going to create options.path. So we create a file at the path that you pass on the command line with the content hello world. And because schematics are already rules and factories are rule factories, you can actually call a rule factory with an object and with a list of options and get a rule. So you could technically just return another schematics like that. But how do you extend it? Well, we provide a lot of basic rules for you that makes composition and reusing really easy. For example, we provide chain, which chain basically chains multiple rules. And because the output of a rule is conveniently the input of another rule, we can just pipe them together, so chaining them together. And we're going to chain the other schematics with our tree.create that adds to the other schematic hello world, a file containing hello world. So if the paths already exist, or if the paths was created by another schematic, then this is going to do an error. In a system like Yeoman, for example, you might end up with another schematics being run, the files being committed onto disk, and then you try to create a new file at options.path, that file exists, it breaks, but the other one just ran, so your file system actually is in an inconsistent state, and you have to git revert or maybe try to find out what happened. But in this case, if options.path already exists, it's going to discover that when you try to create, it will lead to an error down the line, and it will just prevent the whole system from being run. So this whole schematic will fail. But calling another schematics rule factory, so there is a little bit of helpers that we provide to create the options object. It's not just an options object. There is a schema. You can make a schema associated with it, and you can put like default values for some of its values, or you can compute some values with other values. And that logic is kind of lost if you call it directly as a function. So what we provide is the schematic rule, which calls another schematic by name with a set of options. And these options are going to be validated and then run against the schematic before running the other function. How do you get started with schematics? It's simple. So we provided, you have to install globally the schematics, the Angular DevKit/Schematics NPM package. And you have to use, it depends on the core, the DevKit core, and it depends on RxJS. And then we provide to you a schematics that helps you create schematic automatically. That's called @schematics/schematics. And so the schematics library provides you with a command line tool that's also called schematics. And that command line tool, and there is a schematics inside the schematics library that creates schematics, and so this is also called schematics. And so, I'm so sorry for the transcript, but to create a new schematics, you call schematics at schematics/schematics :schematic -- name equal Angular, the name that you want to give to that schematics. Yes, and so, or you can use the CLI. You can pass a collection to, and we'll talk about collection in a bit. You can use the CLI to actually remove one schematic from that command line if you don't like it. The difference, I just want to point out that the difference between schematics and CLI, the schematics command line tool, is that we only suggest the schematics for debugging. There is a lot less configuration that happens and validation that happens before schematics. So if you guys are targeting Angular CLI, then you should use the CLI at some point in your workflow to debug using the CLI. And then you can CD into AngularConnect. For our example, we're going to go into the new schematics that we created, and we're going to extend Angular, the schematics for Angular that we provide by default. So we released all our CLI templates basically as schematics as part of at Angular/schematic at schematics/Angular. Sorry. And creating the schematics will create a bunch of files. We'll go through all of these files. There is a lot of documentation in there that we're just going to skip. I suggest you guys, if you want to try it, you just try the command line previously, and then you just read through the documentation. This is really close to all the documentation that we can provide for now. Inside the package JSON, you'll notice that we added a new key that's schematics that point to a collection. A collection is basically a package of multiple schematics that contain a name and then a bunch of options. Like, for example, for this example, what we're going to use for the collection is we're going to create a new schematic that's called my schematic. There is a description, so if you do ng help, you're going to get the description. There is a factory, and optionally, the factory points to the rule factory, and optionally, there could be a schema in here. If you want an example of schema, there is a schematic that contains a schema and all the validation that we support. And the factory itself points to the rule factory, which is in index.ts inside the my schematic folder. And so that function looks like this. So my schematics takes a list of options and return a rule. And then we call chain as we did before. But instead of calling schematic, we call external schematic, which takes two strings and an options object. The two strings are pointing to the collection and the schematic inside that collection. And then we just override, we just write over the component.css to pass in the selector and say that the color is red. So this is just a simple example of how you can extend an already existing schematic inside the Angular and add your own customizations to it. So what comes next? What is the roadmap? So right now, schematics has just been released as part of 1.4. We are working on a lot of the documentation, but also a lot of features that you guys are going to enjoy a lot. For example, we are working really hard at allowing you to extend collections. And what I mean by that is one part of reusability is that you want to basically just change one part of a collection that already exists. Like you want to change our components, but you still want to keep the others, like the generate module, generate spec, generate interface. You want to keep all of those as is. So you want to extend the collection. So you can You can merge multiple collections, so we're going to allow you to merge multiple collections with different override options if you want to override some schematics from a different collection with other schematics from another collection. So if you have a company that has like multiple collections, and for a project you need multiple of them, then you can just merge them together and export them so that people can use them in engine generate. And another thing is maybe you want to reuse the same collection, reuse the same schematic that already exists in another collection, but you want to just change one part of it. So one thing that we're going to provide is the ability to add rules that will be applied at the end of other schematics. So for example, if you want to add the copyright notice at the top of every source files, you could have an add copyright rule that is added to all the schematics that already exist in another collection, like the Angular collection. And of course, you can mix and match merging and extending to really go further and apply rules to some part of a schematic or some other. Also, we want to add tasks. So one of the big problems currently is that because schematics have no side effects, well, this is a huge pro, but also schematics have no side effects, which is a huge con. And what we want is allow you to basically be able to use NPM or package manager, so that if the user, you just say, I want to run the install command on my package manager because I changed package.json. And we can already know if the user uses yarn or NPM or the Chinese NPM, because they use a different one in China, for example. So you can just say, I want to install packages at the end because I changed package.json. And if multiple schematics ask for that command, we can just execute that command once because we know what it is. And we don't need to use npm install. We'll use the one that the user actually uses. Or you want to call git commit at the end to put a little pretty message or something. Or you want to use a database connection to update the database, your Firebase, only when the schematics have been successful. So if there's a problem generating schematics, you don't actually run the database update. And all of these are coming really, really soon. This is one of the next things that we're going to work. And finally, we want to have another command in the CLI that will be, we call it add, but name pending for now, that adds support for a library. So you have a project that already exists. You don't necessarily know, and you don't necessarily want to read like millions of tutorials on how to configure Firebase or install native scripts on your app and create like a bunch of files and all the dependencies and the imports in your ng modules. And so you could use ng add native script for that particular workflow. And we will work with these third parties to make sure that these are compatible with the CLI applications as they are today. And finally, we kind of used our own add schematic scope on NPM for our own stuff so far. We have 2 schematics, but we're going to add a few more in a bit. We want to open up that to basically everything that's endorsed by the main team are going to be part of the add schematic, so that you don't end up with random packages on NPM that you don't know if it's endorsed or not. Nobody knows if like @Paul/native script will be the official native script NPM package. Then we would like to be part of the add schematic so that you guys know that this is officially supported and endorsed by the Angular team. And so that is basically everything that's on the roadmap for schematics. And with that, I'm going to let Mike come back on stage to pop a little bit back the stack and go back to the CLI.
Hey. I'm Mike again. So I promised you that we would talk a little bit about the roadmap of what's coming in the CLI and the DevKit in 2018 and beyond. So no promises on time frame, except today plus N. is the way I like to refer to it, that sometime in the future, eventually, that these are some of the things that we'd like to be able to accomplish with the flexibility that we're providing within DevKit beyond schematics and Build Optimizer, which are wonderful additions to the CLI and DevKit. So without that, or more schematics is something we want to add an additional functionality within there. You saw some of the power that's really just like surface level of things that you can do. There's going to be a lot more that we can do with schematics and a lot more customizations that we can add, as well as things, if we're adding those things, then those are things that you can extend with your own schematics as well. So adding on to what we already have there. PWA support. Mentioned earlier, the 1.6 is supported in Service Worker 5. So that's currently in beta, and we're going to work to refine that to support PWAs through Service Worker at Manifest and the other pieces of PWAs so that you can get all the tooling for PWAs right out of the box with the CLI. Library support. A few of you, maybe like a handful over the entire Angular community, have asked for libraries. That's something that we're definitely working towards. We know that you want to be able to build libraries separately, not just applications, and it's something that we definitely want to support. We hear you, we want to work on it, but again, we're doing some internal cleanup, moving the dev kit that's going to unlock possibilities, like doing things like library support to be able to build libraries with the Angular CLI and the dev kit. Build hooks. As of right now, you have two options. You run your build through the CLI, or you eject and you run your own. And those are the two options that are there. So we want to be able to provide a little bit more granularity, whether or not it's just pre and post hooks or additional granularity to tap into the existing build system. Excuse me. So that will allow you to tap into the build system, whatever that ends up being, whether or not you're tapping into Webpack. There were also some talks here about ABC. Actually, I think Rado's talking about that later on today, about Angular basal enclosure. So whether or not that's the build system, to be able to tap into that to enhance your build process for your applications. Also, by moving things from a interface, a user interface, being the command line, into a library, the possibility of being able to tap into generations isn't just the command line thing. It could be a library that's consumed by an IDE. So imagine the possibility of, from Visual Studio, to be able to say, file, new, get a list of the schematics that are there from that IDE or any other IDE, to get that list, get that help to be able to have a user interface, to be able to find that if you're not so fond of the CLI or any other command line interface. So that's a possibility, or even a completely separate GUI. I know that there's some initiatives to be able to do a UI on top of the CLI right now, but it's a little difficult because you're taking an interface, a user interface, tapping into another user interface. So it'll clean it up by being more of a library in the dev kit. Also, add automatic updates. So talk about the ideas of what Hans had started on, is that you have a tree, and then you add some rules on top of that, and you get out another tree. Well, that doesn't necessarily need to be just generating an existing file. But maybe, so the example I like to use for this is with Angular 2 to Angular 4, the breaking change was to go the tags with a tag of template to ng template. Well, there's really nothing stopping you to write a schematic to say, hey, I'm going to look through your code, and I'm going to find anything that starts with template, and I'm going to replace that with ng template. We've just upgraded an application from Angular 2 to Angular 4 by applying one rule. So any other rules we could also discern for any other future breaking changes to be able to apply rules to your system, look at your application, make those changes automatically for you, and spit out updated code for you. And that's just not limited to Angular. If you are updating another library that they decide to provide some sort of schematic scripts to be able to update your application for their libraries as well, if you're using any other third-party libraries. That functionality is all open to be able to tap into that. And as Hans mentioned, ng add. So scaling up a new piece. So the example I like for ng add is Firebase. You have to add your Firebase configuration somewhere. You have to add your npm installs to package.json and a few other things. But to be able to do all of that in a consistent way for you is very straightforward and something that's easily tapped into via schematics. So there's some of the things that we're looking forward to being able to expose and tap into the power that we're going to get out of the dev kit. So thank you for your time. Thank you again with Hans and Filipe for the work that they've done within the CLI, and thank you for coming out.